Hey guys, welcome back to the channel. Thanks for tuning in. On today's episode, we have something that's pretty exciting. It's a brand new tool, and it is a CNC. So stay tuned and let's see what we got. So we just received this order in. It's only part of the order. It came from Open Builds, right there, Open Builds. Now, in Canada, there's a distribution company called Maker Parts, and that's who I got this from. I am not sponsored by Open Builds or by Maker Parts. I purchased this kit, so I'm going to give you an unbiased opinion of it. So let's get into this thing and see what it is. Okay, so I've unboxed this box here and this box here, and I'll show you what we got. And I gotta say, they've done a really good job of packaging this stuff and labeling it. Everything, like I got a whole box here of empty bubble wrap. Everything was bubble wrapped and shrunk wrapped and packaged very nicely. So that's encouraging because you don't want this stuff to get damaged in shipping. So what we have here is a bunch of extruded aluminum pieces, and these are the rails for this tool. And then all of these that I've laid out here, these are all the various fittings and brackets and just all the hardware, as well as the power supply and the actual control box. And then I also ordered this router. So if you haven't guessed by now, this is like a CNC router table, but it is a fairly compact version. It's about a foot by, or 10 inches by 40 inches of cutting size or something like that. We'll figure that out. But yeah, that's what it is. So these are gonna, there's gonna be like two X-axis rails and, or two Y-axis rails and an X-axis gantry, and then also a Z-axis sort of plunge up and down that's gonna move this router up and down. And yeah, so it's pretty exciting. Now, this system is definitely designed to cut wood and plastic and foam and those other things, but I'm actually hoping to cut aluminum with this thing too. So I have a couple of things, of pieces that I've ordered to cut aluminum, and in addition to aluminum, I also want to hook this thing up to it. I'm going to show you what this is right over here. So this is a Hero Cut plasma cutter, and I did have a different plasma cutter before, and I got rid of that thing because this one here is a non-high frequency start. I was really trying to get a cheaper plasma cutter to work on a CNC table, but the cheaper plasma cutters are high frequency start, which interrupts all of the electronics in the computer and the controller. So this is a non-high frequency start. It's like a, I can't remember. I'll get back to you with what type of starting it is, but this one is specifically designed for a CNC table, even to the point where it has on the back here, it even has a CNC control signal input on it, so you can actually plug a CNC table right into this. So yeah, the idea is we're going to use this plasma cutter along with this CNC table to cut out parts. Not huge parts, but definitely smaller parts. And I have found that the majority of the parts that you cut out anyway are small. If there's any big parts that need to be cut out, I'll ship those out and have those cut off site. But we can also do routering for both cutting like flat sheet form, 1/8, 16th inch, probably 3/16. You could even do, well, whatever thickness you can do. You just have to do multiple passes with a router. And yeah, so let's get all this stuff here sort of laid out on a table, and we're gonna look for some assembly instructions and probably just start unpackaging these in order of installation. So let's keep going. kind of wanted to give you an update of where I'm at. I have the general frame already put together. 3 of these short pieces across here and here, 2 long pieces here and here, and then there's these funky sort of C-shaped extruded channels that are on here as well. So this frame, I also have some of these little brackets. I'm not sure what these are for. These might be actually to screw down like a piece of MDF or a piece of plywood for a milling surface. But this frame part is together so far. Looks pretty good. I'm pretty excited. And then on the table here, I'm starting to assemble. A lot of these are the these are referred to as the large extreme wheels and mini extreme wheels. It's kind of a bearing that has a chamfered edges on it, and I think the whole idea is that this wheel actually runs in the extruded piece like that, so it can't move side to side because it's kind of locked in there. And that's the principle that this machine uses. It doesn't use linear rails or any other system. It actually uses this style of sort of chamfered bearing. They call it an extreme bearing, and that kind of rides in that groove. So I have all of these assembled. You had to push in all the bearings and have a little shim in between, the small ones, the large ones. And now what I'm doing, actually just to note how I'm actually going about this, is over here actually I have a flat screen TV hooked up to a computer, and I'm just watching the video. They don't actually provide assembly instructions with this, but the video seems to be pretty informative. It shows kind of the next step here. It gives you a breakdown of all the pieces that you need to find. You know, we're on step 5 right now, and you know, we need to pull all these pieces together, and then it'll show you how to assemble them. So the video is pretty good. The hard part is it shows all these parts, right? And it calls them like, the hard one I had finding was this, the M5 black nylon hex nuts. So that's what it says over there. But when I get back to these little baggies, this baggie doesn't actually say anything on it. It doesn't say M5 hex nut on it. So that would be kind of nice if they did that. But it's not horrible. What I do like is that they have given some of the measurements, like these ones here are 60 millimeters long, so they put 60 on them. These ones here are 27 millimeters long, so they put 27. So they do give a little bit of instruction. This one here that says self-tapping. This one here says 20, these are 1-inch bolts, it's 25 millimeters. So it gives you a little bit of description, but some of them just have nothing on them. The spacers are kind of nice, like these spacers, this is a 9 millimeter spacer. This is a 6 millimeter spacer right here. This one here is some sort of, they call it an eccentric spacer, probably because the hole is not centered in the spacer. So yeah, I would give this probably, I don't know, the video is good. The video is good. The packaging is good. The labeling is not great, but it's still a good solid 7 to 8 out of 10. Like, you got to do a little bit of thinking, but it's not too bad. Anyway, enough talking. Let's keep going with building this. We're putting some of these wheels with these bolts on this bracket. This is one of the gantry brackets. So let's keep going with assembly. Update. I've gotten a little ways anyway. Each of the gantry sort of side brackets is done. I have all the bearings, the little wheels on there. This is the anti-backlash adjustment. So this is where the actual threaded rod goes to that moves this back and forth. And they give you some adjustment to kind of tighten up the thread so that it doesn't move back and forth on the threads of that rod. Here's the other one. I also have the, I guess you'd call this the Z-axis gantry kind of thing. So this is going to go up and down on the X-axis. So yeah, let's keep going. We have more hardware there, still a bunch of stuff over there. So we'll just keep going. Quick progress update. So we have our base frame kind of all together. We have our gantry installed. All the bearings are adjusted and kind of snugged up so it moves quite freely. This way, I think, is Y. This way is X. This way is Z. So this here moves along the gantry quite nice. There's like zero play. It feels actually quite tight. So yeah, it's coming together great. Nothing's actually, sorry, the Z-axis threaded rod is in. This is called a lead screw. That's what it is, lead screw. The lead screw for the Z-axis is in. The NEMA 23 motor is here with a little gear and a little ribbed pulley to the lead screw, which the lead screw attaches right here. There is the anti-backlash threaded block here. So if this, when this turns, I don't know if you can see it on camera, but this goes down, turn it the other way, and it goes up. So that's great. We're gonna work on putting the lead screw on the gantry next. We're still following the video on the screen. We have the parts laid out for the next step, which I think is putting the motor on here. I think we're putting the motor there, or we're putting the motor there. Anyway, let's get back into the time lapse and let's keep this thing going. It is pitch black out there. It's almost 10 o'clock. I'm going to call it a night. But for now, I'll just give you just a quick update. Still following the video on the screen. We have the motor completely, the rig completely assembled as far as the mechanical structure. This is the gantry right across here again, and the Z-axis that goes up and down. And so really we've gotten all of the, the screw drives here installed on both sides, and on the back of the gantry here all the motors are installed, and I've actually started on some of the wiring, so that's pretty cool. Right now I've connected all the wires to the motors, and I've mounted the limit switches, and I've connected the sort of lead wires to them. The next step which I'm gonna do on a different day, is to start to label all the wires, the other end of them, so that when I connect them to the black box controller, I know which wire is which. And then we're gonna proceed with routing the wires through all of this extruded aluminum. The cool thing about this aluminum is when you route the wires, you can actually push the wire into this channel here, and they give you this plastic cap that will cover the wiring. So we'll be able to route all of the wiring properly through this channel. So a lot of it's going to be tucked away. And for the parts that move on the gantry, of the Z-axis that moves on this X-axis, the main gantry, and also on this Y-plane, we have this cool, kind of looks like a chain. And it's just a plastic runner here that has a hollow section in the middle that we can run the wiring through, and that will allow the wiring to kind of do that. So it's not all flailing and out in the open to get damaged. It'll all be kind of tucked away and be nice and neat on this. So gonna call it a night. We're gonna pick this up on another day. So yeah, we'll stop here right now. So we got all the wiring complete. We have all the wiring tucked up nice and neatly over here in the corner. Most of the wiring runs through this cable tray right here, which runs along, hoops around and up to the sort of mobile part on the X gantry. So it actually came out quite neatly. Grayson helped out. Thank you, Grayson.
No problem.
So yeah, we have our LED light working when the power is on. We have our wiring coming through, like I said, to over here. Also, we have another one on the Y-axis that brings all of the wiring back to this location. And this is where we have our black box installed. And so this unit actually mounts to the side of the frame, so it's nice and secure. It has a cooling fan, has a bunch of different functions that maybe we'll get into later. We also have a power supply here. It's a 120 volt power supply that takes it down to 24 volts, connects into here. So that is where we are at. Now we've calibrated it. We've downloaded the software. We've done a few settings right now just to sort of calibrate it right now. As you can see, we actually have an alarm right now. When it hits a limit switch, it alarms. This is how the limit switches work. And that's pretty much it. We haven't cut anything. We've only calibrated it. So the next step is to get something onto the machine and start cutting. What do you think?
Nice.
What do you think we should cut? No idea. No clue. Awesome. So let's get something on the machine. Let's get something cut. Also, one thing to note: the first thing we are going to do is we are going to actually router. We'll probably router some wood. The eventual plan is to be routering aluminum and any other non-ferrous materials. So this is just a standard DeWalt 120 volt variable speed. It's called like a mini router or something like that. We have the Open Builds router mount, so this actually is designed to accept this router right here. So yeah, that's how we're going to start. We're going to start with routering out some wood. I have a 1/4 inch collet, and I actually purchased a 1/4 inch bit. So let's get some design on the computer and some wood on the table, and we'll cut something up. All right. We've cleaned things up a little bit around the table to give us a good working surface. I did go to the hardware store. I bought some 3/4 inch MDF, and I've gotten a really basic kind of cut file here on the Open Builds CAM software, moved it over to the control software, and yeah, that's kind of the shape, just maybe like a 6x6 sort of bracket with some 1-inch flanges. So it's pretty straightforward cut file, just only for test purposes for now. So let's get this OSB or MDF, sorry, on the table, screwed down, and then we're going to do a couple of mock cuts. We just want to get this machine moving around and see if it'll do what I want it to do. So yeah, let's keep going with this MDF on the table. Great, so I don't know if you saw in the video, but this thing did move around and it did its little fancy cut. It was in time lapse, so it probably happened so fast that you couldn't really see it. But I just ran it through that shape and it seemed to run totally fine. Actually, it was very easy to do. I just sort of set the XY at 0 right here. In fact, right now, if I click on go to, let's just see here, I'll click on go to X0 and the machine will easily move back to the location where I set the XY0. And then I also set the Z or Z0 just up pretty high. So normally what you would do is you would place a piece of material here, you know, a piece of aluminum or wood or whatever you want to cut. Once it's attached down, you move the gantry and the bit to the corner of that piece of material. And then you also set the height to the top of that material. And then you set each one of these to 0, or you can set all 3 of them to 0 with this little button right there. So what we're going to do next is we're going to just take a piece of scrap MDF that I had left over. We're probably going to screw it down to this piece of MDF that's here, just because I don't want to cut into this piece yet. This is the sacrificial piece, but it's also the mounting surface for you know, a bunch of work that I want to do. So I prefer not to router into it until I actually have to. So I'll mount another piece of MDF right here, and we're going to mount our DeWalt router, which is right here. I have a 3/16 cutting bit for this, and so we're going to get all that set up. We're going to set the 0, and we're going to actually try and cut a piece of MDF, and we'll just kind of see how it goes. We're just going to engrave the piece of MDF for now. We're not going to cut all the way through, because I just kind of, well, I want to see what it's going to do. So yeah, let's get all this stuff mounted, and let's see what this thing can do. Alrighty, well, huge success. This is exactly the piece that I had drawn up on the software. I'd used Fusion 360. I actually drew this in the sheet metal form of a Fusion 360 with these flanges all bent up. And then I, flattened the form in Fusion 360 and then exported it as a DXF into the CAM software, did all the settings in the CAM software, into the control software, and then I simply just click the run job button after sort of zeroing out everything, the height of the material, and I set the 0 for the XY around here, and then I just hit run job. Well, first, so this router right now is literally just plugged into the wall, and I'm just flicking the switch on it. So turn on the router, run your job, and then flick the switch and turn it off. I think there's probably some sort of relay settings on this, on the little black box here to control the router itself, but I don't probably actually really care too much to control the router. I'm not going to be cutting out enough where I need to actually turn on the router and turn off the router, at the beginning of the job and the end of the job. I'll just let it run. But this cut is fantastic. The bit that I have on there is a single flute. Let's see if we can see the bit. Single flute 3/16 carbide cutting bit. Yeah, it's just kind of one of these things. They're not cheap. The bits for these routers, the good ones that have the 1/4 inch sort of shank on it and the good carbide cutting bit, like these things can be anywhere between, somewhere from $30 all the way up to $100. So these things are not cheap. So you really don't want to break too many of these. But yeah, this is awesome. I'm super excited. Like, this is the very first cut on this machine and it worked great. The machine's not too loud. The one thing that I need to figure out particularly, well, it's going to be an issue. Right now, cutting MDF, like MDF dust, the actual dust this puts off, is super fine. And it makes a mess. Like, it's all over my laptop, it's all over the mouse, it's all over everything. So probably what I should have done is just had a shop back here and been sucking in as much dust as possible as I'm actually cutting. Now, aluminum is going to be even worse. And I've routered aluminum before, and it puts off little filings that are just like little tiny aluminum slivers. And they are not pleasant. And when you mix them with cutting oil, man, it's hard on the hands, like it's hard on your skin. And really, like, this is not a shop environment. Like, I got my Mustang here and I got open racking all over the place, and then I got my wife's car over here and bikes, and all of this stuff is just going to get coated in aluminum shavings or MDF dust or whatever it is I'm working on. So for routering itself, I'm going to have to figure something out. Something to sort of harness all of that dust or chips or whatever. So I'm not sure yet what I'm going to do. I've seen some people put an actual vacuum attachment around the router itself that works, that somehow has clearance around everything and it's not too bulky. I got to figure something else. Like, one cut and I got like dust all over the place. And I need the little open limit switches here, little circuits. So yeah, bottom line, I'm gonna have to figure something out. But I am super stoked. Like, this is great. It's just awesome. So anyway, thanks for watching this video. It's something that I've wanted to do for a long time. I didn't mention in any of the earlier videos, but prior to what I do now in my current career, I actually went to school for mechanical engineering, and I actually worked at a fabrication shop here in town, running a table like this. It was a lot bigger. It was like 5 feet by 10 feet, I think, and it was more heavy duty. It had a 3-phase spindle attachment that did the actual cutting, and it was way more robust. And we used to cut for 10 hours a day. We would be cutting aluminum, we'd be cutting wood, we'd be cutting styrofoam, we'd be cutting plastic. Primarily, we cut aluminum though for aluminum fabrication. We built a whole sort of variety of aluminum products, from boats to vehicle parts to lots of stuff. So that's kind of what I'm reminiscing about when I actually purchased this machine, is what I used to do when I was younger. This is like 20 years ago now that I used to do this. So yeah, it's cool, it's fun, it's small, it'll cut what I need to cut, I'm hoping, probably a lot slower than what I was used to in the past, and that's okay. Like, the thing about this machine is it's just a hobby, it's not a business. So if it takes longer to cut what I need to cut, that's just fine. And yeah, we'll just have to learn how to use it in the maximum capacity for what I can do here. One thing that's pretty cool is, if this machine proves to be super useful, I can actually get longer Y-axis sort of aluminum extruded bars here, and I can make this table longer this way. I just got to get, longer little screw drive thingamajiggies rails here. The motors will work. It's got 2 motors that run the Y-axis. And I can actually build this thing, it's modular, so I can build it longer with just ordering a few components. The software, the motors, the controller is all capable of extending this thing longer. I could literally make this thing twice as big if I found that the cutting surface right now is just not good enough. But that is for a future video some other time. So that's going to be it for this one. Thank you for watching. Please like and subscribe the video. I'm new to this. I don't put out a lot of YouTube videos. I actually have a fair amount of videoed content, but the whole editing and posting process is a little bit slower for me. I got a family, I got 3 kids, I got a business that I'm running. All of this stuff is just a hobby for me. So thank you for your patience. Stay tuned.